Hello everyone, welcome to this presentation. My name is Jonatas and today we will explore one of the most fundamental tools in data science. Regression analysis is widely used for modeling relationships between variables and predict outcomes. And I'm excited to dive into this core functionality, type, and real-world application implementation in Python. So let's get started. To begin, let's define regression analysis and its importance in data science. As a core, regression is a statistical technique that helps us to understand a relationship between a dependent variable and one of or more independent variables. It allows us to make predictions and gain insights into how changes in input variables can affect outcomes. Regression is not only a foundation technique in data science, but also a versatile one. Used across various industries from healthcare to finance, marketing, and beyond, whatever predict on sales or forecast trends, regression has been used as much in these fields. So now let's dive deeper into this functionality. Regression's core functionality is centered on modeling relationships between dependent and independent variables. Essentially, regression helps us to predict outcomes based on historical data. The most common form of regressions, linear regression, aims to us to model a relationship between fitting a straight line through data points. One of the key advantages of regression it allows us to make predictions. For instance, once a regression model is built, we can forecast future values based on a new input data. Additionally, the coefficients of regression models are interpretable, meaning they tell us how changes in dependent variables will affect dependent variables. Here you can see a simple diagram showing input data, a regression line, and the predicted outcomes. The line represents the best fit, which minimizes the error between the predict and actual variables. There are several types of regression, each serving different purposes. Linear regression. This is the simplest form of regression, used when the relationship between the dependent and independent variables is approximately linear. For example, predicting house price based on square footage. Second is logistic regression. Despite its name, logistic regression is used for binary classification tasks, such as determining whether an email is spam or not. And the third is polynomial regression, when the relationship between variables is not linear. We can see polynomial regression. This type of regression fits a curve that's data capturing more complex nonlinear relationships. Here, we've included simple graphs to illustrate these different types of regression. As you can see, linear regression uses a straight line. Logistic use a curve, and polynomial regression captures more complex trends. Now, let's explore some real-world applications of regression analysis across different industries. First, forecast trends. Regression is often used to predict sales, stock prices, and other business metrics based on historical data. This helps business make data-driven decisions about budgeting and investing strategies. The second is risk assessment. In finance, regression is used for credit scoring or in insurance to model risk and predict claims based on customer profiles. Healthcare analysis. Regression can help predict disease outcomes, such as the progression of cancer or optimize treatment plans by analyzing patient data. And for sure, marketing customer analytics. Regression is used to predict customer lifetime value, and analyze price elasticity, helping companies to optimize pricing strategies. Now, let's take a closer look at the use case to understand how regression works in practice. So, imagine you are working on a house price prediction model. The dataset we are using may include features like square footage, number of bedrooms, and age of the property. Using linear regression, we train the model to predict the price of a house based on those factors. Once, once the model is trained, we evaluate its performance using metrics like mean square error, for example, which tell us how accurate our model is predicting the house price. As low indicate as better fit. The flowchart here shows the key steps: data collection, pre-processing, training the model, and evaluating its performance. This process allows us to build an effective regression model for price prediction. To implement regression in practice, we use data science tools like Python. Libraries such as Panda are essential for regression analysis. Here's a sample Python code snippet for training and evaluate a simple regression model. First, we use pandas to load and pre-process the data. Then, skitlearn to create the regression model. And finally, we use matplotlib to visualize the results. For example, this can be used to train a linear regression model using training data and makes prediction using test data. Python makes regression implementation easy and clear syntax and strong support for visualization. While regression is a powerful tool, it does have some advantages and limitations. Let's take a look on this. Some advantages are simplicity and interpretability that makes linear regression models straightforward to implement and easy to understand, making them ideal for generating insights. Then we have prediction and insight generation. Not only can regression predict future outcomes, but the coefficient also helps us to understand the relationship between variables. But we have limitation as well, as linearity assumption. Basic regression models assume a linear relationship between variables, which may not allow us to hold true, particularly for complex data. As well, we have sensitivity to outliers. Regression models can be highly sensitive to outliers, which can skew results if not handled properly. In conclusion, regression analysis is a foundational tool in data science, widely used for understanding relationships between variables and making predictions. Its simplicity and interpretability make it accessible, and its application span industries like healthcare, finance, marketing, and real estate. Tools like Python make regression easy to implement, allowing data scientists to quickly turn raw data into actionable insights. I encourage you to explore regression further, as it is a critical skill for anyone looking to data-driven decisions.